Here it is given that a thin spherical insulating shell of radius r, and it is having the charge uniformly distributed over it. It is having the potential at the surface is V0, and then what you did is you have made the whole of the area alpha into 4 pi r square into it. And then after making the whole, what is going to happen to the V center upon VR by 2, then what will be the V at center reduced by, and in this way you have to find the answers for the different conditions. Now first of all, I'll just find the V at center. So V0 is going to be kq by r, because that is the potential due to the volt charge on the shell. Now what is the charge of the cut portion, that how much charge has been removed? So for 4 pi r square the charge was q, then for alpha into 4 pi r square obviously the charge was alpha q, and that alpha q amount of charge has been removed. Now what is going to be the V at center? So initially V at center was V0 by, obviously it is going to be V0, which is nothing but kq by r. But now as you have removed this portion, so naturally that potential will get reduced, hence it will be k alpha q upon r. This much amount of potential has been reduced. So this is nothing but V0 1 minus alpha. So V0 minus V0 alpha means the V at center has been reduced by alpha V0 and not by 2 alpha V0. So this is not the correct answer. Now what will be the V at a distance of r by 2? So again, due to whole part it will remain same, it is not at all going to change, but due to this cut portion the potential is k alpha q, and at a distance of r by 2 from here, so it is r by 2, means it is V0. If I take out kq by r common and saying it as V0, this will be 1 minus 2 alpha. So this is V at r by 2, and if I take the ratio of them, then V at center upon V at r by 2 turns out to be 1 minus alpha upon 1 minus 2 alpha, and hence the answer option A is the correct answer. Now we are interested in E at the center of the shell. So E at the center, initially it was 0. Why? Because it is a uniform charge distribution shell, so there is no charge enclosed inside, and that's why the field inside the spherical shell is 0. But now, because of this alpha q, there will be field at the center, and how much will be that? It is going to be k alpha q upon r square, which is nothing but alpha v0 by r. So alpha v0 by r is the increase in the electric field. Here it is said that E at the center of the shell is reduced, so which is definitely wrong, and also it is not reduced by alpha v0 by 2r. At least if I would have said that E at the center of shell increased by alpha v0 by 2r, then it would have become a sensible statement, and even though that answer will be wrong, because alpha v0 by r is the increase in the field at the center. Now E at 2r will be reduced by, so simply E at 2r, so I'll just do here E at 2r. For finding E at 2r, you will have to first find E due to total and minus E due to cut portion. So how much is the E due to total? So it is going to be kq upon 2r whole square minus E due to cut, that is alpha q upon r square, because it will be at a distance of r only from the cut portion, and hence it is going to be kq by 4r square minus k alpha q upon r square. Now here again it is in terms of alpha v0, so this was the original. If I write this also, even though it is not needed, I'll just write it in terms of v0. So alpha kq by r, that is v0 by 4r, and it is reduced by k v0 by r. So by how much that field has been reduced? It is going to reduce by, I'm sorry for this, it is going to be alpha v0 by r. So it is reduced by alpha v0 by r, and here it is given that alpha v0 by 2r. So definitely this is not the correct answer. So only answer option for this question which is correct is E. A sphere of radius r is having a charge q uniformly distributed over it, and there is another cylinder given whose radius and height are varying according to the options. And we have to find the flux, that is the electric flux through the cylinder because of charge enclosed by it which is lying on the sphere. Now for the first option, if we go, I have drawn the figure here for saving our time. So H is greater than 2r, means H greater than 2r, so naturally it will be coming out like this, and the radius of the cylinder is 0.8r, means its diameter of this will be 1.6r, and it is very well lying within the sphere. So the figure for first option will look something like this. Now for getting the flux, we need a charge enclosed by this cylindrical surface, and for that I should know one very important relation to get that charge, which is a relation between the solid angle and a linear angle. Now the relation is sigma equal to 2 pi 1 minus cos theta. So this is the relation between the solid angle and a linear angle. Now you might be having a question that how this relation arrived. So for that I am giving a link in the description. You just click on that link and you will get the complete derivation of how the relation between the solid angle and the linear angle has arrived. Now I'll move ahead by assuming that this is correct. So sigma will be equal to 2 pi 1 minus. Now what will be cos theta in this case? Cos theta will be 0.6r upon r, means it is 6 by 10, means it is 3 by 5. So this is 1 minus 3 by 5. How much this is going to become? This will be 4 pi by 5 is a solid angle. Now we know that over the complete part, means over the solid angle of 4 pi, if the charge which is there is q, then for 4 pi by 5, how much will be the charge? Q by 5. Means the q by 5 amount of charge is here. So naturally how much will be the total charge enclosed by the cylinder? So total charge enclosed by it is 2q by 5. Now if the total charge is 2q by 5, what will be the flux? Net charge enclosed upon epsilon 0. So the flux in that case should turn out to be 2q by 5 epsilon 0. But what is given here is q by 5 epsilon 0. So this is definitely an incorrect answer. Now I'll go for the second option. Now second option changes slightly. This is greater than 2r, but instead of 4r by 5, this is 3r by 5. Means this part turns out to be 0.6. So naturally the same triplet, this turns out to be 0.8r. So only difference will be here that instead of 3 by 5, now it is going to be 8 by 10. So it will be 4 by 5. Now because of that, instead of this 4, it will turn out to be 2 pi by 5. Now for 4 pi, if it is q, then for 2 pi by 5, how much it will be? It is going to become q by 10. Now if it is q by 10, then the total charge enclosed will be 2q by 10, which is nothing but q by 5. And if the total charge enclosed is q by 5, what will be the flux? It is going to become q by 5 epsilon 0. Now this is there in the second option, so definitely this is the correct answer. Now think of the C, H less than 8r by 5 and r less than 3r by 5. So looking at these values, it clearly indicates us that this cylinder is completely lying within a sphere. Now there is no charge enclosed by cylinder, so obviously there will not be any flux, and hence the flux through the cylinder in that case will be 0. Now if we see carefully that this H greater than 2r and r greater than r, it means now for the fourth option, the sphere is completely lying within the cylinder for this condition, and hence the whole of the charge on the sphere is enclosed by this cylinder. So net total flux because of this complete charge for this cylinder will be q by epsilon naught, and hence the fourth option is also correct answer. So answer options for this questions are B, C and D. An electric dipole is kept here, and it is said that the dipole moment of that electric dipole is P naught by root 2 I plus J. It is also said that it is held fixed in the presence of uniform electric field E naught. Another information which is given is the potential is constant at every point on the circle, means that circle is a equipotential surface. So from this figure and these two conditions, we have to check which options are correct. Now, first of all, that if the circle is an equipotential surface, then the field at every point on the circle must be perpendicular to it. Now, if I see the point B, then at particular point B, if you see the field due to the dipole is in this direction. And how much will be its magnitude? Well, it is going to be Kp naught by r cube. So this is the field due to the dipole at point B. Now we know that if it is an equipotential surface, then there should not be any field in this directions. The field should be only perpendicular to it. So your E naught one component, so E due to external, should be in such a way such that it cancels out the Kp naught by r cube. But there is equal possibility that this external field is somewhere in this direction, which will have its vertical component and horizontal component. There is a possibility. But if we assume that possibility that it has a component in this direction, then here also at this point A, the field will have a component in this direction. Now, how can you have the component of field in this direction if the potential or the surface is an equipotential surface? Because if I see the field at this point A due to dipole, it is in this direction. So external field is in this direction, and if there is no one to cancel out this component, it means here also there will not be any vertical component present. And hence your external electric field, which you are calling it as E naught, must turn out to be Kp naught by r cube, and because of that the field at B must be 0. So from here itself we get the two options. One option is the field at B is 0, and another important relation is for the radius r. So here r is going to be K, means it is 1 upon 4 pi epsilon 0. This is P naught upon E naught, and this raised to 1 by 3. So this is the radius. So this is another important relation we get for it. Now if suppose I want to find the total electric field at point A. Now who is responsible for the total electric field at point A? Now there are two factors. One is definitely the external field, which is E naught, and another important is parameter or there is the field due to dipole. Now how much will be that? It is going to be 2p by r cube. Obviously there is K, so 1 upon 4 pi epsilon 0 2p by r cube. Therefore the net total field at A is nothing but E due to dipole plus E due to external part. So how much will be the E due to dipole? It is 1 upon 4 pi epsilon 0 2p by r cube, and plus E due to external, which is nothing but E naught, which is 1 upon 4 pi epsilon 0 p by r cube. So if I solve this, I'll get 1 upon 4 pi epsilon 0 3p by r cube. Now 1 upon E naught is how much? Well, E naught is 1 upon 4 pi epsilon 0 p naught by r cube. So this is all about the p naught by r cube. So it means it is turning out to be 3 E naught. Now how much is that p naught in vector form? Well, if I want to write, this is the magnitude, so E at A, if I want to write in a vector form, then EA bar will turn out to be 1 upon 4 pi epsilon 0 3 p naught by root 2, this is r cube I plus j, and hence I'll get this as 3 E naught by root 2 in the bracket I plus j. So this is the field at A, so definitely this is not the correct answer. Now the last option talks about at any point on the circle the E total is same. Well, it is not going to be same. From here itself I can understand that E at A and E at B are different, and even logically you can conclude this, that this is wrong. At any 2 point on the circle it is same is wrong, because even though the external field is same, at every point on the circle the field due to dipole is different. So naturally the net total field at 2 points will be different, and hence even this is not the correct answer option. So the answer option for these questions are B and C.